All right, so if nobody has any questions, we'll just jump into a review of, what do you call it? Descartes' rule and some bound stuff. The book does not tell you about upper and lower bounds, but to me, upper and lower bounds are a little more useful than Descartes in general. If Descartes works, it's amazing. When Descartes doesn't immediately work, it's kind of sucky. It doesn't really help too much. But bounds are very useful, right? Because it kind of sucks. You haven't done enough of this yet. But when you get a list of possible routes and you start trying them out, when they don't work, you're like, oh, come on. So what would be nice is if I tried one and it didn't work, but it still told me something, right? And that's what bounds is all about. If it doesn't work, but all the answers are positive, that could tell you something. It could be an upper bound, right? Okay, maybe. So let's try out an example here. Let me see, where are you? I had one here a second ago. There we go. Let's see, what's a good one? And also, if anybody just came in, if you have questions from homework, you gotta let me know. Here we go, perfect. Okay, got a good example. All right. Let's see, how do I want to do this? Sure, we'll do this. Let's do this up here on the board. Oh, I got to turn my moon off. All right. That's no moon. No, sorry. All right. Now let's try this problem out. This should be funkadelic. I know. Hold on. So let me see here. Whoa, where are you going? Oh, poor little thing. Hold on, guys. It's that kind of day. All right, that'll hold for a bit. This little wheel came off, poor little guy. All right, so what I want you to do, see if you guys remember how to do this. So given this function here, yeah, all right. I think that's it. Yes. All right, so write that bad boy down. Probably don't feel the same about this problem as I do. I love this. It's crazy awesome. Look at this thing. It's crazy. Now, if you got that written down, take a minute. Can you write the complete list of all possible rational zeros? However you spell zeros, I don't know. I spell zeros like heroes. Do you guys remember how to do that? What is it based on, this list?
Multiplication.
Sort of, yeah.
Or division. The factors of 40.
Good.
And of
and
1.
Divided by the factors, but this is nice. If this is a 1, you're like, oh, thank God. So what are all the factors of 40? So you got 1. What else we got?
2. 5.
4.
Oh, 4, 5, 8.
And now once you get to 5, you can start doing the 8 and 5, 10 and 4, 20 and 2, and 40 and 1. All right, cool. Did I forget? No, there it is. All right, so that's the complete list, plus or minus. Does Descartes do much for me here? Does anybody remember, how do I tell the possible number of positive real roots? All right, and I know this is, we had yesterday off, I understand. It's been a little while. But you look at the function as is, how many sign changes do you see? 1
and 2.
So how many possible positive real roots are there?
2.
2 or
0.
0. Yes.
I like it. So I showed you the graphical reason why. Remember, I don't know if you guys remember, but we graphed something and there were 2 roots, and then I lifted it up a little bit, and then there was 1, but it's repeated, so it's got multiplicity 2. So there are still 2, and if I lifted it up just a little more, those 2 disappear and become complex. Here's something else I want you guys to realize. Now, stay with me. This is kind of cool. Here's the algebraic reason behind this. Any complex roots that come from a polynomial function with real coefficients. Are there any complex coefficients? No. Have to come in pairs. Any complex roots that come from a polynomial with real coefficients have to show up in pairs, in specific kind of pairs, conjugate pairs. Now, why does that make sense? Where would complex roots come from as I'm factoring a polynomial? They would come from a quadratic piece that I do quadratic formula on, right? And that bad boy's got plus or minus in it. There you go, done. So it's always got to be complex conjugates, so pairs of complex numbers. That's why this number goes down by 2, because if there isn't 2 of them, they must be complex instead. So there's 0 of them. How do I check for negative? Possible number of negative roots. What do I do? I'm so excited, by the way. I can see more of you. I like that. Thank you for turning your cameras up. That really does help my mental state.
You put in a negative X.
Good. So if I put a negative X in, which ones of these will change sign?
All the ones?
Yeah, the odd power ones, right? So it'll be, let me see if you guys are cool with this. Negative, positive. I'm just going to write down the signs, right? That stays the same. That changes. That stays the same. That changes. That stays the same. So let's see how many changes assigned. 1, 2, 3. So how many negative real roots are there?
3 or 1.
3 or 1. I like it. Okay. So that's Descartes' rule of signs. It either does a ton for me or it does barely anything for me. Can you guys, somebody help me out? If we just started throwing stuff in, would you put positive stuff or negative stuff? What do you guys think? Would you want to put positive stuff in, like try some positive ones or try some negative ones?
Yeah, positive.
Why?
Because I'm used to it.
All right, that's an acceptable answer. But based on these, what is there definitely going to be? Is there definitely going to be any positive roots? Are you guaranteed positive roots?
No.
No, there could be none. Are you guaranteed any negative roots?
Yeah.
Yes, there's definitely one negative root, at least, if not three. Now, I don't know. That might not really be a deciding point for you. I don't know how much of a gambling person you are, but I might put negatives in. Now, you guys, do me a favor. Let's talk about bounds now. So Descartes, look at it as it is. The number of sign changes will tell you that many positive real roots are possible. And then you go down by 2 because you could lose a pair to complex and another pair to complex. Negative roots, I've got to put a negative x in to see what's happening. Okay, and then I do the same thing. I see the sign changes and go from there. Can you guys please divide this thing by 8? I think it's 8. Sure. Synthetically divide. So what is this synthetically dividing by? Really, what factor is that dividing by? If I put an 8 in here.
X minus 8.
Yes, x minus 8. So I'm actually dividing this thing by x minus 8. But go ahead and synthetically divide it. I'll just stand here and, well, maybe I'll go get some liquid. All right. My blue pen. Is it my working pen? No. Okay. All right, let me help you. Let me catch up to you guys. Now watch what's going to happen. Have you guys already gotten far enough to see what's going to happen? This is going to be 43, right? So 8 times 43 is 264. Is that right? No, 344. Is that right? Yeah, 344. You guys with me out there? So this is 309. And then that's going to be like, all right, now at this point, do you understand what's happening? Isn't this going to be big positive? Big positive. I think I've done this once, and this is also big positive, and that's big positive. Because I already know it's not going to work. Are you with me? All I'm interested in now is it a bound of some kind? Did it turn out to be a bound?
Yeah.
Which bound could it be? It could only be an upper bound, because remember, upper bound, divide by a positive number. How do I know it's an upper bound?
It just keeps getting larger positive.
Well, more importantly, it could actually keep getting smaller, but as long as they are all positive. And a lower bound, well, let's see. 8 is an upper bound. So how could I change my... I'd have to throw out positive. Well, I can throw out 8 because it didn't work. So I could throw out positive 8, positive 10, positive 20, positive 40.
Was that -8?
What do you mean? Sorry. It's positive 8. So I could throw out positive 8, positive 10, positive 20, positive 40.
I thought we
I'd have to
changed
leave-
the sign. It was x
It's
minus
related-
8.
It's related to this factor, but what is the 0 of this factor? Positive 8.
Yeah, okay.
Okay. Now, you guys take a minute and do -8 now. divide by -8.
Pardon, what is bound? Did I miss something?
So what does the word bound mean?
Limit, right?
Yeah, sort of. So it's kind of like the maximum or the minimum of something. It's the limits. I agree with you. The limits of something. So an upper bound means that nothing above 8 will work. I like it. And did 8 work? No, 8 didn't work either. So I can throw out +8, +10, +20, +40. I can throw all those out. What do you guys get when you do this with -8? What is that? 27 negative 240 negative 216. Is that right? I think so. Then this is negative 251, and then you get positive. Look here, I'm not even going to write the full thing down. That's positive 1600. This is 1700 something times negative is negative big, which is negative. Now, do you understand why it's okay to do that, what I just did? Is it really 1700 here? No, who gives a shit? It's big positive. That's all that matters. Right? At this point, right about here, I go, well, this is never going to work. But I don't stop, because notice what's happening with the signs.
They're switching.
They're switching each time, which means this might be a lower bound. So that's why I kind of keep going, but I don't have to be precise, because I already know it's not going to work. I just need to see if the signs are changing. I don't know. Are you guys doing okay out there? You got to understand in mathematics when you need to be precise and when it doesn't matter worth shit. So right now I'm like, that ain't never going to work. All I care about now is the signs. So if I divide by a negative number and the signs constantly alternate, that is a lower bound. All right, so now what can I officially do with my list? I can just, everything 8 and above doesn't work, everything -8 and below doesn't work. I can just, let's just do this. I just cross all this shit out. Okay. Now, everybody pick a number and try it. Do you understand what I mean by that? Right? Pick a remaining number and try it, and let me know if you get one that works. Oh, yeah. Yeah. All right. I think I got one. Anybody get one yet?
-4.
So we got, let's see. So somebody says that -4 works. Let's try it out. So let's see. 1, -4, -3, 12, -17, 68, is that right? Yeah. Negative 33. Yeah, negative 152, negative 10. Wait a minute. No, positive 152. So that's not going to work, is it?
It's positive
Oh, that's
33.
not. That's positive 33. Yeah, there you go. It's a rough day for me. Let's see. So that'll become negative 152. That's better. Negative 10.
Is it
Negative
132?
1, negative 152.
So that should be 132. Negative 132.
How bad am I doing?
Under the 142.
120, 132. Yeah, there you go. Good Lord, Jeff. Negative 40, 0. Okay, so that does work. I like it. Did somebody else get something else to work? Anybody?
I tried 2.
Did it work?
I got 0, but I don't know if I did it correctly.
Let me see real quick. Let me see. 2, 1, 2. Like you really believed you could do this in your head after what you just did, Jeff? I don't think it's going to work though. Well, let's see. This is what we haven't had a chance to do together yet. Don't start over here. What have you got so far? I know so far that this is going to be x plus 4 times x to the 4th plus x cubed. Are you guys, I'm sorry, x to the 4th minus 3x cubed minus 17x plus 33. Anyway, I think I'll go off track. Yeah, I did. Let me go ahead and write this down just to be careful. X squared, that's what I left out. All right, is that cool? When I get to this working and when in evenly, I know that it's x plus 4 times that. That's what I have so far. Okay. Wouldn't I then start to tackle this if I was doing this really, by hand, not synthetic division? I'd try to start factoring this. So don't start over. Put the next thing you want to try right here next to this. And you said it was positive 2?
Yes, but I don't think I did it right, so
All right.
it might not work.
Did somebody get something they know works?
It worked out for me too.
Oh, 2 works?
Yeah.
2 works? Okay. Let's see. 1, 2, negative 1. I don't trust myself today. Negative 19, negative. Oh, good. Yeah, you're right. There you go. So you can stack your synthetic division as you go. Something else. Let me see if I can throw this in there. I'm going to take Descartes away. He didn't really help us out too much. Something else, if you have a really long ass list and you get something that works, like I said, don't you on this row have x to the 4th minus 3x cubed minus 17x squared plus 33x plus 10. All right. Do you see how there's a 10 here now, right? Would 4 work anymore? Is 4 a factor of 10?
No.
No, so I could actually throw 4 out. I didn't have to do that because somebody already found another factor for us, but I can reduce my list by looking at what's left here. Because we made the list in the first place based on what was there in here. So as I get things that work, the number that's left might kill some more things. So at this point, I can kill the 4. It's not going to work, but 1, 2, and 5 are factors of 10. Now, would I throw 2 out since it worked? Would I never try to use 2 again? Is 2 automatically out?
No.
No. Why?
It's a factor of 10.
True, but more importantly, it could actually be a factor that has a multiplicity more than 1, right? So it could actually work multiple times. Never throw anything out because it worked. Only throw it out if it didn't. or if it's a bound issue, right? You can get rid of some stuff. Okay, maybe. So where am I at now? So now I'm here. What can I throw out right now from the list?
105.
Well, no. What can I throw out? I can actually, why can I throw a 2 out? Because it's no longer a factor of this, right? Not because it worked, because it's no longer a factor of what's left. Now, did somebody else get another thing that worked? You might have just said it.
5.
5? Okay. Yeah, 5 works. That's the one I got that worked earlier. So it doesn't matter what order you get these to work. If you got 2 to work first, you would have different numbers here, but then -4 would still work and 5 would still work. You guys, right? If I said factor 18 and somebody said 3 times 6 and somebody else said, no, it's 2 times 9, you're both freaking right. Keep going and you're going to agree if you break it all the way down. So it doesn't matter what you get to work first. So if I do 5, 1, 5, 4, 20, become a 20. 1, 5, 0. So what do we end up with here? Let's collect everything together. I get x plus 4. Keep going.
X minus 2.
X minus 2.
X minus 5.
And then I'm stuck right here at x squared plus 4x plus 1. Is that cool? Maybe. So this is as far as I can go over the reals. Yeah, this didn't start off as an equation. So this would be factored using just integers. Yeah. If I wanted to go further, I'd have to use quadratic on that. Okay. Maybe. So just remember what Descartes said. It was 2 or 0 positive, 3 or 1 negative. I got 2 positive, 1 negative, and then these are going to be kind of gross. Okay, maybe.
So if we were told to find the non-real solutions, we would take it further by factoring
Are
that
these
one.
not real? Can anybody tell me very quickly if these are going to come out not real, or will they be real? How does anyone remember how to tell? What part of the quadratic equation tells me if something's going to be real or not? Which part could be imaginary?
The rational or the radical?
Radical. I like it. So what's b squared minus 4ac up here? It'll be 16 minus 4. Positive 12. So this is going to be real still. So this will actually end up being the other 2 negatives probably if we kept going. Well, let's see. Let's keep going. Let's get the last 2 zeros. So we got -4, 2, 5. Let's go ahead and get the last 2 zeros here. Does anyone still need? Is this cool? Do you guys get the point here about the stacking? Once you get something to work, keep working on the reduced thing. Keep working on the reduced thing. Just stack it up like this. All right, maybe. All right, so if I take this bad boy up here, this will be -4, give or take, square root of, we figured out this is 12 over twice 1. So I'll get -2. Let's see if you guys are cool with this. Rad 12 would be 4 times 3, so it would be 2 rad 3 divided by 2 is rad 3. All right, I did that a little bit fast, but are you guys, you see where that's coming from? It's okay if when did we stop stacking? I like it. When did we stop stacking, Kurt? When I got to the point where it was a quadratic. Or if nothing works, right? Yeah. Okay. So pretty cool with that. And notice something. What's -2 minus rad 3? That's definitely a negative number, correct? What's -2 plus rad 3? Is rad 3 bigger or smaller than 2? Rad 3 bigger or smaller than 2?
Smaller.
Smaller, because rad 4 is 2, so rad 3 is smaller. So -2 plus something smaller than 2 is also negative. So how many total negative real numbers did we end up with? 3. How did I get the zeros? I could see them. And also, whenever we got something in a penalty box that worked, that was the 0. So what are the zeros? -4, 2, 5. Why are they called zeros? Because they make them 0. That's why. That kind of makes sense. They're inputs that make the output 0. So whenever you get something in the penalty box that works, that is a 0. Okay, I like it. Maybe. There was a lot that just happened, right? So you might want to watch this again if you need to. So what do we got? We got Descartes, which is sometimes awesome, but most of the time a little lame. We got bounds, which I like. Let me just show you how this problem would look if I put this problem on a quiz or the test, right? I'll show you exactly what it looks like. Because I have this that I decided not to throw up on Canvas because I just found it again. But this is pretty much the way I like to give this kind of problem, right? List all the possible zeros, do Descartes. This is Descartes' rule of signs here, right? Divide synthetically by 8, by -8. What do your results mean? Update your list. So I do like to step you through. It's not just totally do something with this. I try to make A, B, C. You have to interpret what it means, but I kind of guide you a little bit. So your list isn't like huge unless you're lucky enough to notice something. I try to help you cut your list down if you remember what your results mean. Is that understood? Because those lists can get stupid big, especially when I put a number in front that's not 1. Then you have to include all the fractional possibilities. So I don't want to make a test where you have to try 20 things to get somewhere if you're not lucky, right? That's not my goal. So I like to ask these kind of questions where I'm helping you, but you got to remember what it means to be helped. Okay. Maybe. I want to show you something from the homework though. Did anybody try out the synthetic division where they're asking to use I stuff to synthetically divide by? Let me think. What was the one of them? I want to show you something kind of cool. Because I believe I teased the idea that synthetic will work with what do you call it? Complex numbers.
If you're going to do it on the board, we're not going to be able to see it very well.
Oh, thank you. I am open to being reminded about that. All right. I think there was a problem. Let me think. What was it like? Well, you could just look it up, Jeff. Because this is a neat problem. I don't know if I'm going to find it right now. In 5.4, thank you. Yeah, that's the one. You know what I'm talking about. It was right towards the end. And I know some people were like, I don't know how to
60 and
divide.
61.
Yeah, I got you. Thank you. Yeah, let's look at 61. I got something really cool to show you. All right. And maybe you guys won't think it's cool. 61, x plus 1, x plus I. All right. So don't tell me you don't know how to do this. Yes, you do. What goes in the penalty box?
Negative I.
Negative I. You know that. You know it. I is a number. That's what I is. That's what I do be, is a number. So it's just going to act like any other number. And then what am I going to put here, of course?
1, 1.
1, 1. Bring down the 1. Negative I times 1 is negative I. Add. All right. How do I interpret this? It started off as a first power. So now the answer is going to be a constant. So this will be 1 plus, and then remainder divided by divisor, right? All right, let me stop for a minute. Is that cool? Is that satisfying? Not really, but it shows it works. The other one, number 60, is much cooler, actually, with your result, but I'm going to let you guys do that one. Now, watch this real quick. This is kind of cool. I want to show you something. This is useful in a lot of different ways. Just go with me for a minute. And you guys are like, that's all we ever do, Jeff, is go with you. Now let me see if you guys understand what's about to happen. Is it okay to, let me see if you guys are cool with this. I can add something as long as I subtract it at the same time. Isn't that the whole thing we do when we convert quadratic functions into standard form, right? Don't we kind of add something and then we immediately undo it at the same time? So overall, I didn't do anything. So watch this shit. I want the bottom to show up on the top so that I can kill it. So if I put x plus I, don't I have to at the same time subtract I? Right? Let me do the whole thing so you guys. Did I just do anything? Mathematically, did I just change anything at all? Nope. So some of you guys are like, yeah, good job, Jeff. Now stay with me. Now watch. Isn't this x plus I over x plus I plus 1 minus I over x plus I? Yes? Isn't this 1 plus 1 minus I over x plus I, which is what we freaking got? Yes? Isn't that cool? That kind of thing I just did. Let me show you a different problem. And this will be the last one we do because this is a little side note, but to me, it's just so cool. That little thing I just did. So if I had a problem like this, what you got, Jeff? What's a good example? It doesn't matter. Sure. You can do it, Jeff. Sure, I like it. All right. So if I want to make this show up, don't I need to add an x here? So I better subtract an x. Don't I need to add a 1 here? So I better subtract a 1. So then I get x squared plus 5x plus 6 over x squared plus 5x plus 6 minus, well, let's just do plus. Let's just keep it plus, Jeff. So isn't this 1 plus? Okay, I don't know if you guys can see that. That was definitely quicker than like long dividing this, right? Do you guys agree? Wasn't that quicker than long dividing this thing? And it was easy. It's adding, subtracting instead of dividing and shit. All right, anyway, that's a side note. That's nothing you have to fully understand. That's nothing you ever have to do. But I try to show you the flexibility in math that sometimes you don't even know is there. This is kind of cool shit. All right, that's enough of this. There's one little thing about the other problem related to this one that I want to say. I think I said something about this before, but I want to make sure this is true. Do you guys know how to factor this? Or what do you think? Is that factorable? So let me help you out a bit. It's not factorable over the real numbers. But I'm asking you just to factor it over anything.
You can use the quadratic.
No, don't do that shit. You don't need that. So here, let me just tell you what it is. So why is this not factorable for real numbers? Because there's no real number that when you multiply it by itself, it makes a positive thing, and they're not different signs, so there's no way for them to escape. So it couldn't be 4 and 4 because they had to be 8. It couldn't be -4 and -4 because they had to be -8. They don't kill each other. And I need the middle term to kill themselves, right? I need 0 in the middle. Complex numbers are fine because when you multiply two complex numbers, right? If I multiply, what's -4i times 4i? This will be -16i squared, which is
16.
positive 16. I can get positive 16. So this will be x minus 4i, x plus 4i. So if you can factor any difference of squares, you can automatically factor the associated sum of squares. You just put i's at the end, right? So how do you factor x squared minus 1? What's that?
X minus 1i.
X minus 1i.
Or
X
No, you guys are funny. X minus 1, x plus 1. How do you factor x squared plus 1? Now come at me.
right. With the I.
X plus I, x minus I. And now look at, bam. Now look at that number 60 again. And you can see why the answer should come out nice. I still want you to do synthetic, but you should know what the answer is going to be for that number 60 in section 5.4.
Is the second, did you say x plus I, x minus I?
Yeah, my little dot went flying.
Ah.
You make him more of an I. There we go. Right, so x squared plus 9 is x minus 3i, x plus 3i. X squared plus 25 is x plus 5i, x minus 5i. Bam. Okay, I like it. Which, you know, only makes sense because how do you solve this equation? What do? Don't you subtract 16, take a square root, and you get plus or minus 4i? Well, there's the plus and minus 4i. Okay, maybe. All right. So let's do this. Let's go back into what we did last time, which is the asymptotes. Let's kind of review those. I want to talk a little bit more about slant asymptote, which we did at the end of class last time. I use my blue marker. I think it's the only one that's working. So somebody remind me, if I have a function like this, what you got, Jeff? Sure, why not? Okay. Where would the vertical asymptotes come from? So these are the walls that would go this way. Where would those come from? You guys remember?
Bottom.
Say again?
Something makes a 0 on the bottom.
On the bottom, I love it. So vertical asymptotes come from the domain. They are hard walls that you cannot cross, and they're related to X values. So they are X values that I'm not allowed to use. I like it. So where would the vertical asymptotes be for this function? What would I have to do? Factor this. So how does this sucker factor?
Let's say -4.
Okay, so then I'll have a vertical asymptote at -8 and at +4. Okay, so those are the vertical asymptotes. Those are beautiful. Those make complete sense. I put a wall on the X's that I'm not allowed to touch. Okay, I like it. So what about horizontal asymptotes? So there were 3 situations that I could be in. This one is the situation where the degrees are the same. So the 3 situations are the degree on the bottom is bigger than the top, the degrees are the same, or the degree on the top is bigger than the bottom. Okay. So in this case, the degrees are the same, and the shortcut is it's the ratio of the leading coefficients on the top and the bottom. So that would just be 1 to 1. So the horizontal asymptote would be y equals 1. If I make x crazy freaking big, then -1 don't mean shit. And plus 4x minus 32 don't mean shit. So when x gets really big, that's what dominates. X squared divided by x squared is 1. So if I were to set up this guy's walls, there would be a wall at y equals 1. There would be a wall at -8. And a wall at 4. Okay, I like it. Let me stop right there. Have I done anything that was difficult yet? There was new stuff, right? Not brand new, because we talked about this last time, but what I've done isn't difficult, right? I factored this little bad boy, got those, bam, bam. I've got to understand my 3 situations for horizontal asymptote, but when the degrees are the same, it's the ratio of their coefficients. So y equals 1, because it's 1 to 1. Bam. And we're almost done with this graph, which is crazy. We haven't done anything, it feels like. We really haven't done much. But now I know it's either going to be here or there. It's going to be up here or down there. Now, it could actually be like this. We'll have to see. Now, this is what I needed to talk about with horizontal asymptotes. Horizontal asymptotes are like end behavior because they come from letting x get really big. That's the whole point of horizontal asymptotes, is what happens when x gets really big. Is x really big in here? Is x? No, x is not really big in here. It could do whatever the hell it wants to. In fact, later this semester, we'll see a situation where I have a function that goes through its horizontal asymptote an infinite number of times. Is it getting closer to the asymptote? Yes. So that's completely allowed, right? This is still awesome. This would be like plucking a guitar string. Thank God over time, the frequency diminishes, but it's still oscillating, right? But it's oscillating less and less and less and coming back to a normal state of being still. Thank God they stopped vibrating. Imagine if every guitar string ever plucked was still going. Just think about that. Okay, now stop thinking about it. Okay. Can somebody tell me, do you guys know the intercepts, the X-intercepts? Can anyone see the X-intercepts? How would you determine the X-intercepts? Say again?
Is it -8 and 4?
No, because those are the values that make this undefined, right?
Would it be -1 and 1 because of the top
Yes.
being
So
equal
if
to
the
0?
bottom is 0, undefined. If the top is 0, the function's 0 then, right? The only way for a fraction to be 0 is if the top is 0. So that would mean that my intercepts are at plus and -1. My scale sucks here, but well. I can see my y-intercept is 1 over 32. I mean, so it starts to come together. It looks like it's probably going to be like this. All right. Anyway. I don't want to go too far. We'll come back. We'll do a whole problem here in a minute. I don't want to do it here in the middle of everything. We have to finish what our idea of the horizontal asymptotes are. So here, let me show you this. I got something a little more organized than I seem to be capable of tonight. So I've got something up on Canvas. Everybody hope Canvas is still working. Let's see if I've made it accessible yet. Where did you go? Here it is. All right, let me make this accessible. Now let me show you guys what I'm talking about. Okay. Let me become a student so it looks the same for you and me. So if you go right now to Canvas and you go to Unit 5, there's graphing rational functions. Also to remind you guys, there's this narrowing list. So is this where I put that one? Oh, cool. Look at all this shit here. Yeah, I think this is the one we did earlier. Yeah, okay, I forgot I put this up here. This is awesome. So we did this problem earlier up on the board. And up at the top, I've got all the definitions for bounds and Descartes rule assigned. So that's been up on Canvas for a little while. I forgot that I did that. And then this one is the one I just made accessible, graphing rational functions. Coolio. Okay. So if you look at this, this is a whole problem. I think I want us to try to do this one, and then we might call it a night. But look right here. I've tried to summarize the idea for horizontal asymptotes. If the bottom degree is larger, let this make sense. If the bottom degree is larger, it's growing quicker. If I'm dividing by bigger, I'm getting smaller, I'm going to 0. If the degrees are equal, like the one we just did, then it's y equals a over b. It's the ratio of those. And if the top one is larger, that's where we get a slant asymptote. And we do need to focus on that, but let's not do slant yet. I tried to do a little bit of a slant one with you last time. That might have been a little too early, but I wanted to show you an example of all 3 of these. So let's see what we can do on this thing here. I'm going to open this a different way so it's easier for me to look at. Are you guys all able to access this sheet? Anybody? Nobody?
Yeah, I got it.
Okay. Let me see if I got that somewhere. Where are you? Factor graph. What the hell? Here we go. This has got to be it, right? No. Well, shoot. Maybe I'll just download this real quick. I don't know where I put it at. All right. So, oh yeah, this is gross. Let me do this way. So go ahead and start working on that sheet. I'm going to catch up to you here in a minute. All right, this should open up better. There we go. By the way, did you guys hear that Texas is basically opened up again?
What do you mean?
Texas is there's no more mask mandate and everything's open. The governor's mandated that everything must open, all restaurants, everything.
Isn't it
And
snowing over there?
Huh?
Isn't it like snowing over there?
A little bit. Texas is one of the top positivity places. Per test, they have 12.3% positivity per test, which is, anyway, I'm sorry. That's all beside the point. It's just really infuriating. I just noticed I still had that open. So let's look at this. Intercepts. So when I say intercepts, that means all intercepts. So find the X-intercepts and the Y-intercepts. So does anyone, how do you find the X-intercepts? This one will be nice. Y-intercept is really easy. Oops, somebody's chatting at me. Yeah, yeah, yeah. Especially like Cruz's blind spot is bigger in Texas. Anyway, I'll stop. It's gotten a lot harder for me to not talk any politics at all in class, but I try not to. I don't want anyone to feel uncomfortable here. Well, that's becoming less and less true, but all right. Anybody got the X-intercepts? What do I look at to figure out the X-intercepts?
The top half of the function.
Yeah, the top. The only way a fraction can be 0 is if the top is 0. So the top will give you X-intercepts. The bottom is going to eventually tell me what?
Asymptotes.
Vertical asymptote. Okay. I had a point to that. All right, I like it. So X-intercepts, you can, everybody should be able to see that. You take a 3 out and you get X plus 1, X minus 1. So your X-intercepts are 1, 0, and negative 1, 0. Okay, no big deal, right? And what's your Y-intercept? If you plug a 0 in, you're left with the ratio of the constants. So what do you get?
2.
Who? Say again.
Is it 1/2?
1/2. There it is. Okay.
1 over 2, yeah.
Oh, I'm sorry. I only got the vertical asymptotes. So what do I have to do to get there? I just have to take the bottom and factor that bad boy. Oh, good question. So when I'm finding X-intercept, I'm actually setting this equal to 0. And the very first thing I could do is divide by 3. So the 3 doesn't do anything because I really want this to make sense. 3 is 3. Could I do anything to X to make 3 become 0? There's no X attached to 3. So 3 doesn't give me anything. Okay. So I could just divide it away because it's a constant. I could divide by a constant all day long. So what do you get when you factor the bottom?
X plus 3x minus 2.
Kick ass. So then my vertical asymptotes are
Negative 3 and 2.
coolness. I like it. Okay, what situation are we in for horizontal asymptote?
The degrees are the same.
Degrees are the same. So what will my horizontal asymptote be?
3.
Yes. So the ratio of the coefficients of the highest degree terms, right? So this is beautiful. I showed you last time the more technical way to get it was to divide everything by the highest power and so forth. This is a nice shortcut. So y equals 3 is my horizontal asymptote. All right. And then I normally am pretty nice about this. I do sometimes give you some, but well, to be honest, let me turn that around. I'm normally not this nice. But for this first one, I gave you some things to try. But if you plot the X-intercepts and you plot the vertical asymptotes, what's the last thing I want to, let me think, how do I say this? What's the last thing I want to assign to my graph? You've seen me do this a few times by now. What's the last thing we sort of figure out before we finish graphing the whole thing? And that might be too vague of a question. I don't know. I can't figure out my y-axis scale until I have a few more points. So I see what their outputs are, right? The x-axis scale, I can just go by 1 because my intercepts and my asymptotes aren't going crazy. I like it. So I can make this axis by 1. And if I plot my intercepts, 1, 0, negative 1, 0. And I plot my vertical asymptotes, negative 3 and 2. All right, try not to think about it because I was doing pretty good there. All right. See, you guys are kind of with me. So I don't know what's happening out here at all. Do you see how I have no information out here? Crap. Get out of there. I really want you to understand why I picked these points. So you can see why I picked -4, because I don't know shit out here, right? I do have intercepts in here, but I don't know shit out here. And I am going to have a y-intercept in here too. So this middle section needs no more information. It is good to go. But I need something out here and something out there. So I picked -4 and 3. That's why I picked those. So what do I get when I put a -4 in? And I normally do that into the factored form. But of course, I didn't fully factor the damn thing. It's too bad for me. So this is normally the first thing I do. So if I put -4, it'll be 3 times -3 is -9 times -5 is 45. Let me know if I'm wrong. And then -1 times -6 is +6. I think that's what I get. So what's that come out to be? 15 halves, so 7.5. Is that what that is? Okay. And it doesn't matter. You don't have to plug it into the factored form. I just like to do that because I'm weird. So then you plug a 3 in. 3 times 4 is 12, times 2 is 24, over 6 times 1 is 6. That's nice. I think that's right. 3 times 4 is 12, times 2. Yeah, you did good, Jeff. Yay. Okay, okay. So now I have a little more information. I know back here. So what do you think I want to make my y scale then? If I've got my y-intercept is 1/2, I want to go to 7.5, right? So what's a good scale?
Two.
2? I agree. That's not a bad scale. -2, -4. I don't need too much down here. All right, cool. Now we can, what's the thing I want to put on there before I go too much further? I want to put my other wall up there, right? Where's my other wall? Y = 3. Put my other wall up here. Now that I know where the hell's going to go on my scale. Cool. Now I can put my y-intercept. My y-intercept was 0, 1/2. So it's going to be about right there, maybe. So it looks like in the middle. And what's the multiplicities? Oh, shit. Hopefully you guys are with me. What's the multiplicities of my x-intercepts? That's pretty easy. What's each of their multiplicities?
1, 1.
1, 1. So they're going to go through. I like it. So it's kind of obvious what's it doing in the middle. It looks like it's doing this. Through, hits there, through, down. I like it. Hey, Mikey. Now the actual peak is probably not here, but this is good for by hand. This is what I want to see. This means you didn't copy it out of the calculator. F of -4 is 7.5, which is right there. F of 3 is 4, which is right up there, and that makes sense. Why do I know, even before I plot those, why do I know it can't be down here, for example? Oh, shit. Why can't it be down there?
Because it's over the line.
How do you mean? I mean, before I plot that, if I didn't have that point, how do I know that it isn't down here? what would I need here to
You don't
be
have
able to,
any more X-intercepts?
there you go. No more X-intercepts, no more doors to get through the X-axis. Here I got a door, I've got a door. Yay! I got no door. So I pretty much knew it was up here. So this is just kind of giving me an anchor point so I can go through. So we can extend this a little bit. So here comes wee. Well, I missed it anyway. Good job, Joe. Wee. Oh man, it's disjointed as hell. And then here I've got another little anchor point. It comes wee. Ah. Okay, that's really bad. It should be going up, but screw it. It's good enough for by hand. It's good enough for government work. And then, of course, you could throw this in the calculator. You can double check it. Do not adjust anything unless something is completely out of whack, which means you probably want to check your work. Remember what I said. I want your graph to match with your work. You lose the most points if your graph is good and your work doesn't agree with it. That's bad. Okay, maybe. All right. So let me see what time we got. Yeah, let me see. All right. I'm going to keep you guys a little bit longer because you guys had yesterday off and I really didn't. So I just want to talk about Slant Asymptote real quick, and then we'll call it a night. All right. We're going to obviously do more with this, but I really want this to make sense. Let me see if I can make a better example than I was trying to make at the end of class last time. So if I have this here, all right, let's see what this comes out to be. Neato. Yes, this will go up to YouTube as soon as Zoom is finished processing it. Yes. Sometimes it takes them a long time for some reason. So the whole idea of horizontal asymptotes is let X go to infinity, negative infinity. Let X get big. That's the whole idea behind horizontal asymptotes. Obviously, if I let X get really big, this is going to go faster. It's going to grow faster. So this whole thing goes to infinity, but it's going to do it in an orderly way. It's not just going to go, wah! It's going to do it in a very systematic way. I can figure out what that way is if I long divide this, because what's going to happen is the remainder is going to go to 0. And what's left is kind of like what governs the asymptote. So I have to do long division on this, right? I have to. Too bad for me. Well, to be completely honest, anyway, no, we're going to do long division. It would be really gross otherwise. So I'm just going to do this kind of quickly, right? X squared times X squared is X4. So then I get X4 minus X cubed plus X squared. Change the signs, negative X cubed plus 2X squared. Bring down the negative X. I'm going to do this a little quickly. X squared times negative X is negative X cubed. That'll be plus X squared minus X. Oh, that's neat. That's not what I intended. I don't know. Just made this shit up. Change the signs. These cancel, of course. X squared. This is 0. Bring down to 1. X squared times 1 is X squared. That's crazy. I'll get X squared minus X plus 1. That's neat. Sorry, I didn't mean for this to happen. And then, so all I have left is a plus X, right? So I have plus X over X squared minus X plus 1. Can anybody tell me if I let this happen, what happens to this? If I let X get really, really big, which piece dominates?
Bottom,
Sorry?
on the bottom.
The bottom. So if the bottom grows quicker and quicker than the top does, then the whole thing is going to go to 0. That will always happen with the remainder, because the remainder, by definition, will have a bigger degree on the bottom than the top. That's basically how I know where the hell to stop when I'm dividing, is when I get to something less than this. So this goes to 0, which means when x gets big, this looks like this. Oops, shit. Forgot you one. Sorry, buddy. Now let me see. I think maybe this would look up. This is going to look better on Desmos. And then I'll let you guys out of here. So let's take a look at Desmos real quick. I'm excited. I don't know how you guys feel. Oh, what I just realized is that is so cool. That's a total coincidence. Oh, shit. Anytime a coincidence happens, a student's going to get screwed over. That was a complete coincidence. I almost made something that was a perfect square. That's neat. Thanks, Rio. Okay, so let me do Desmos real quick so you guys can get out of here. Let me see. Where are you guys? There you are. Here we go. Let me share this. Shit. Oh, I can't wait to be back in the classroom. Okay. So if we put, oh, crappity doodah, Jeff. All right, let me see. Can somebody read it off to me by any chance? Oh, let me do. Oh shit! What have I done? All right, can you guys see Desmos still?
Yes.
Anybody? Yes. Okay. So it's x to the 4th. Nobody can help me?
Minus
Oh, okay. Thank you.
minus 2x cubed minus 3x squared minus x plus 1 all over x squared minus x plus 1.
All right. Now look, you can already tell that the end behavior of this thing is parabolic, correct? So let me put in here what we got: x squared minus x. Man, that 2 looks huge. Plus 1. So let me zoom out on this. So do you see how? So this is the function. This blue line is the asymptote. That is so cool to me. I'm sorry. So asymptotes don't have to be linear. They are just what the function does when x gets really big. So look, in the middle, is it close? Right in here, when x is small, does it look parabolic here? No, right? It looks janky. You guys agree with me? I'm in the bring janky back. That word's got to come in. Now look what happens if I let x get really big on either side. Is the distance between the blue and red lines getting smaller? Hell yeah. Jeez. And then they basically become the same thing. Look at that. How far can we go out? Jeez. I mean, out at this level, it looks like they're the same graph, correct? That's the whole point of an asymptote of any kind, is it eventually has to follow the asymptote. I have to come way in to really see the difference. Okay. Okay. I think that's enough. Oh, what was supposed to be a joke? I'm sorry. Did I make a joke? No, that wasn't a joke, dude. I mean, there's nothing to take personally there. I just never wanted to teach online, ever wanted to. I'm not saying I'm not having a great time, but I think you can agree with me. Maybe. I don't know how you guys feel. Has anybody ever taken distance ed before the pandemic?
Yes.
A few of you guys? Is anybody ever, this is your first, since the pandemic, that was the first time? It's the worst? Okay. It kind of depends on your teacher too. So you don't have to tell me right now if I just suck online or not. Maybe I do. But I just never wanted to teach online. I'm trying the best I can. I think it's doing okay. But
Doing a very good job.
everything takes longer. You guys can probably agree. Everything I want to do takes longer. Grading something, I've got to click multiple buttons. I've got to do this. It's insane. And also, of course, that too, man. I don't really get to know you guys. So many of you guys, I couldn't even pick you out of a lineup because, and I'm not saying you have to turn your camera on, but I don't know what you look like, right? So it's anyway, we all know these things. I have no idea why I'm going on this rant right now. But oh, I'm sorry. I like that. See, I want some honesty. Somebody in the chat is saying you're much better in the classroom, Jeff. You kind of suck online. Okay, I understand. I can take it. All right.
What's your
So that's it.
estimated time of this all to blow over?
Dude, personally, I'm really sure we'll be back on campus in the fall. Is that official? Hell no, that is not official. But considering how vaccines are ramping up, considering that every Grossmont teacher should be vaccinated within a month. Do you guys understand? I'm going to get vaccinated as soon as I can find a frickin' appointment. Because my hospital, Kaiser, is behind. I have no idea why they're behind. They're not all the way up in their tiers. So I'm trying to find an appointment through some offsite super station or something, a vaccine station. Yeah, and then of course, it really depends on how many students can get vaccinated.
I'm actually kind of surprised at how many jobs are like getting it for their employees. Like I work for the safari park and they're like, you need it.
Oh, interesting. Yeah, I know they expanded their essential services considerations, I think, like, but I didn't know the specifics like that. Yeah, so if any of you guys have anybody that's taken the vaccine, if you have any more suggestions on how to find somewhere, I would take it. I've got many and nothing is available yet, so we'll see. Anyway, sorry, I went off on a major rant at the end. Well, there you go. Look at this. Jordan, you see that?
Oh, I know a few keepers, but I'm not a keeper.
Oh yeah, and Kurt, Quemock has given vaccines. There's nothing about subsidizing stuff. It's free. Wherever you go get the vaccine, it's free. It's not going to cost you anything. So it's not a question of money to cover expenses. It's just a question of supply. So they're ramping it up. So who knows? All right, guys. So that's enough of everything. So I'll see you guys tomorrow. Let me know if you need to hang out, if you have any questions. Don't forget, the quiz should be active now, I believe. Let me see. So if you want to start it now, you can. It's not due until Friday morning. And I do have office hours tomorrow, 2 to 3. So if you don't want to start it until later and you want to come to my office hours, that's completely fine, if that makes sense. All right. So I'll see you guys later. Let me know if you have any questions.
Thanks, Professor.
Have a good night.
All right, you too.
Bye.
See you. Yes, Abbas, what's up? Abbas, are you there? Yes. 5-1 through 5-4. Yeah, it's actually 5-1 through 5-3. I ended up not putting division up there just because, I don't know. I had plenty of stuff to use without putting division up there also. So yeah, so it's 5-1 through 5-3. All right. Everybody else good out there? I'm going to head out if I don't see any questions. All right, I'll see you guys later.